Hello, Assalamualaikum. My name is FARHAD SYED ILHAM. So today I'll be doing lab 1 so for analog 2. So we will first do inverting operational amplifier. So this will be the first value for RF, which is 4.7 kilo ohm. So I already did the calculation. We should get around negative 4.70 gain and 4.7 volts. So this is our circuit. So I'll simulate. So after simulating, we can see that we have gotten the waveform. So the blue one is for V in and green is for V out. So we get around 4.68, which is around 4.7, and negative 994 millivolt, which is negative 1. So next, we'll be changing the RF to 10k. So the calculation for gain, we should get around negative 10, and V out should get around 10 volts for inverting. So we change here. So after running the simulation, we got 9.98 volts for V out, which is around 10. And if I adjust here, we should get around negative 997 millivolt, which is negative 1 for V in. Next, we'll be doing for the 33 kilo ohms for RF. So for 33 kilo ohms, we'll be getting a clip. There will be a clipping for the voltage out, because okay, there's a clip here around 13 volts, and as you can see, the value of V in is still the same, but the voltage out is clipped. So according to our calculation, we should get around negative 33 gain and 33 volts for V out, but for experimental we only get negative 13 gain and 13 volts for V out. So I'll be answering the question why the output waveform has been clipped. So clipping occurs when the voltage in times gain is more than the voltage source. So for this one, we only use 15 volts for V source. So 15 volt is max. So we only get 13 because it's impossible to get the same voltage as the V source. So 13 is the maximum for this operational amplifier. So that's for the first question. So 2, why is it called an inverting amplifier? Because it's called an inverting amplifier because, as you can see, we insert a negative voltage, so we're getting a negative wave here, but the output we get is in positive phase, so it inverted from negative phase to positive phase and amplified the voltage. That's why it's called an inverting amplifier. So next we'll be going to non-inverting operation amplifier. So this is the calculation I did. So we should get around 5.7 gain and 5.7 V out. So this one is the circuit. So after simulate, we should get around that value. So C2 is supposed to be around 1, so this is around 1, and C1, the voltage out is around 5.7 volt. So we got around what we calculated. So for 10K, we also did the simulation, so we got around 11 gain and 11 voltage out. So as you can see, I already did the simulation. So we get around 10.97, which is 11, and 991 millivolt, which is around 1 volt for 10 kilo ohms at the resistor. So next will be RF 33K. So like the inverting amplifier, we should be getting a clip off, because as I said, the maximum should be only around 15, but since it's impossible to get 15, we already get 30. So it's the same as the uh, inverting, so we get 1 millivolt and 13 volt for the output. So why is it called a non-inverting amplifier? Because as you can see, the voltage, the phase when we entered is uh, positive phase, and the output is also in positive phase. So it did not invert any of the phase, so it's called a non-inverting amplifier. So what does the non-inverting mean? If a sine wave is connected to the operational amplifier plus terminal. So the non-inverting means that when we insert this uh, sine wave into the inverting non-inverting input, so it becomes a non-inverting amplifier, because in this condition the waves will not change phase after it has gone through the amplifier. So for discussion, the we have proven that the output and the input is what we're supposed to get. Through this calculation, we calculated and got the same experimental value as that we wanted. So we proved that the the circuits, so for this one, as you can see that the non-inverting, we get the phase is the same, so positive phase, the output will also become positive phase. And for the for the inverting, we get negative phase when it turn to positive phase. So it proves that the theory that we learn in class is true, because in class we learn that inverting is when the phase changes, like from negative phase turns to positive phase for inverting, or vice versa. Or for non-inverting, we got the same phase after is the phase that goes in is the same as the phase that goes out. So if we enter positive phase, the output will also be positive phase. So in conclusion, we got the output that we wanted, and we learned how the op amp operational amplifier functions, which we have to state, which is inverting and non-inverting. I think that's all for my presentation. Thank you.